Derivatives. If you are instructed to give a derivative of this x raised to power n, you multiply with a power and subtract 1 from the power. Please note, do not first subtract 1 from the power, then multiply with a power. That will be wrong. You first multiply and subtract. Simple as that. This x raised to power 4. We first multiply with power and subtract 1 from the power. That will be 4x raised to power 3. Give the derivative of this 4x raised to power 6. Derivative. Multiply by this 6 and subtract 1 from this 6. That is giving us 24x raised to 5. But if you have to give a derivative of the constant, you must always remember that the derivative of the constant is 0. If they say show how you got that 0, remember that any base raised to 0 is equal to 1. So if you take this constant, during derivation of this, we place x or any variable on here. This variable is raised to 0 once this is done. Then we multiply with power and subtract 1 from power. So, because we have multiplied with 0 here, it changes everything to be 0. That is why the derivative of constant is 0. Remember that any constant or variable with no power, that means it is raised to power 1. Let us give the derivative of this expression. In such an expression, we derive each and every term we have in that expression. We derive this first, multiply with this 3 and subtract 1 from this 3. Second term, we multiply with 2 and subtract 1 from this 2. Third term, we multiply by 1 and subtract 1 from this 1. So, it is 9x raised to 2, 4x raised to 1, but the 1 is usually not shown. On the last term, there is power 0 on this x. Please take note that x raised to 0 is equivalent to 1. Remember the basic exponential law with roots. That is, if there is the square root sign, we must always rewrite it in exponential form, where it is gonna be this, which is from inside the square root sign, then is raised to power 1 over 2. The square root sign is equivalent to half if there is no number or variable on these positions. Every number or variable in this position is going to be the denominator when you exponentially change it. And any number or variable in this position is going to be the numerator when you change this expression to exponential form. We revisit this because the derivative focuses on the powers. You cannot derive such an expression unless you change it to an exponential form. When it happens, you are given such an expression to derive. Remember to simplify it first, meaning you solve the parenthesis through multiplying by this x every term inside parentheses, which will lead the expression to be this form suitable to be derived. Then you derive each term. First term, multiply by 4 and subtract 1 from the power. Second term, multiply by 3 and subtract 1 from the power. And last term, multiply by 1 and subtract 1 from the power. All these lead to this expression.